Good afternoon, good morning, everyone. Thank you for joining in on our Tech Talk today and welcome. So today we're presenting optimizing plant performance with data analytics, loop performance monitoring, or LPM. My name is Liwei Huang. My colleague Lance Rudolph and I will be presenting today's Tech Talk. A few housekeeping items before we start. We have taken a screenshot of an example of the attendee interface. You should see something looks like this on your own computer screen. The control panel hides automatically when not in use. You move your cursor to bring it back. You have the opportunity to submit text questions to Lance and me by typing your questions into the Q&A box of your attendee interface. You may send in your questions at any time during the presentation, which will last approximately 30 to 35 minutes. We will collect these and address them at the end of the presentation during the Q&A session. As a reminder, all attendees are in mute mode and today's presentation is being recorded, and the recording will be provided to you by tomorrow for your reference. Throughout today's presentation, we have 3 poll questions which will pop up on your screen when the time comes. Please respond to the poll questions to the best of your knowledge. We appreciate your cooperation and looking forward to your feedbacks. Disclaimer, please note that as we are sharing information with you today, the slides you're about to see are subject to change. ABB does not assume responsibility for any errors or consequences of software or hardware described in today's presentation. Before we start, a safety moment on winter holiday safety tips. Fire hazard. Keep the decorations at least 3 feet away from heat sources, for example, candles, fireplace, and etc. Water the natural Christmas tree constantly to keep it from being dry. Turn off the space heater before leaving the room. And ensure installed smoke alarms are in working order. For trips and falls, ensure cables and extension cords are securely run so not to create hazard for trips, and use caution when climbing up a ladder. For winter driving for us in the north, be aware of the road conditions and drive at the proper speed for the conditions, and be a defense driver. So today's presentation again is on optimizing plant performance with data analytics, the performance monitoring, or LPM. In today's talk, we'll discuss the following. We'll do some introduction and talk about business challenges. We'll go through the LPM features and the benefits, and we'll give you a couple of examples of past implementations and ROI analysis on those. We'll talk about the LPM solution. How is LPM solution delivered? And we'll give you a use case so that you can have a visualization of how it's being used. And then we'll talk to you about the new developments on the LPM. So please allow me to introduce today's panelists, my colleague Lance Rudolph, Director for Digital and Advanced Services at ABB. He has been in the automation industry for over 27 years, encompassing project engineering, project management, and engineering management. He specializes in DCS, data, and advanced services and digital solutions. He enjoys working with customers in understanding their challenges and opportunities and designing solutions to meet their needs. Once again, my name is Liwei Huang, Digital Lead, Technical Consultant for Advanced Services at ABB. I've been in the automation industry for over 29 years, and I'm specializing in advanced process control solutions. At this point, I would like to pose a poll question. So the question is, how often does your facility assess your control loop performances? Continuously, daily, weekly, monthly, on demand? Your response is greatly appreciated. Please take a moment just to answer the poll questions, please. So I see that people are still trying to answer the question, and give another second or so before we close the poll. Okay, so the poll is closed now. I see that actually over 70% of people responded by saying on demand. In other words, they don't do plant performance assessment on a continuous basis. Thank you again for your response. So Lance, to start off, can you talk about the business challenges that our customers are facing and LPM is trying to address?
Yeah, so hi everybody. So good to be here and have this opportunity to talk with you. I really appreciate it. I want to talk to you about how to get the most out of your base level regulatory controllers. The first thought I'd like you to consider is, what does your business or company actually make? And I'll just pause a second and let you think about that question. In most cases, when I ask people that question, the first response is that we make some type of product. So gas, chemical, fuel, power, etc. But I would say that what probably is common to most of you is that irrespective of the products that you're producing, you're actually all in the business to make money. So with that in mind, what we're really talking about here is how to help identify and address issues in the PID control layer of your automation systems that result in lost opportunities to make more money. These can normally be grouped into how to improve plant stability and or efficiency, i.e. make more, improve the quality, reduce the energy costs, reduce consumable costs, how to minimize downtime by understanding the current health of the equipment and being proactive wherever possible to repair, and finally, making effective use of the people that you have available to get the work done. In other words, know who to send where and with which tools to address the issue. And by doing all of this, we try to maintain and optimize the cost of producing or making money for your organization.
So at this point, I would like to open up for another poll question. The question is, what is the number of PID control loops that each control engineer is responsible for? You have a choice of less than 100, between 100 and 500, or greater than 500. Again, I'll give you a few seconds to answer the question, please. And we'll go on from there after the poll is closed. Okay, so the poll is closed. I didn't see any. Oh, okay, there we go. So it looks like mostly is between 100 to 500. So that's good. So that's a pretty good number, between 100 and 500. So it's quite a number of loops that everybody is responsible for. So now, Lance, let's give, if you don't mind, please give an overview of the LPM features and the benefits.
Sure. So imagine if there was a way to use simple PID data that's already been collected and stored in your DCS or in your historian, and then automate the analysis of that data through some analytics or mathematical equations that represent years and years of research and domain knowledge in terms of interpreting the data, and then using the outcome to generate an easy to understand picture which gives you a visual of the health of all your PID loops. Being able to use this view to quickly navigate to the areas where where you can have the biggest impact on basically being able to make more money. Having this information available and updated on a daily basis with a quick and easy way to see where the issues really are. So most of you responded that you're doing this kind of analysis on demand. So when you've got a problem, what we're trying to do here is automate that process so that you proactively know where your areas of opportunity are. So in addition to having access to ABB experts that can review these analysis and draw conclusions and help with the remediation activities, it's also possible to configure certain what we call monitoring rules that will look for very specific scenarios and enable subscription and push notifications to be triggered when those scenarios arise from the data and analytics. So Leeway, if you want to move to the next slide, having all this information easily available with the basic analysis complete is a key building block in any continuous improvement process. So you need to baseline, you need to measure, you need to know where you are to know what you need to do to improve. So just like the process control itself, our solution allows us to measure, track deviations from industry best practices or your own baseline, and then execute on a continuous basis remediation activities to drive the business results towards improvement.
Great, Lance. So at this point, I'd like to talk a few. So there are many LPM installations throughout the world and various industrial processes. I'd like to mention two examples where LPM has been implemented. These examples show how LPM addresses customers' concerns and brings value to our customers. So the first example is a power plant in the US. LPM was implemented as a part of the multi-year service contract. The customer needed a monitoring system for speedy process issue identification. And especially when most of people, when you had the second poll question, you're talking about you're responsible for 100 to 500 loops. Imagine you have to do that manually, right? So that's exactly what they're facing as well. But they want to get a speedy issue identification going through a large number of loops, and also continuous monitoring systems so they can sustain the performance improvement and address the issues as they occur. So we implemented LPM solution, which includes automatic and continuous identification of performance issues, graphic displays with drill down capabilities to present KPIs that are understandable and actionable. And once the issue identified, ABB helped the customer with the corrective actions to address them. And like I mentioned, this is a multi-year contract to ensure improvement is sustained. The annual economic benefits are estimated at $100,000 range, resulting from engineering and energy savings. The second example I'd like to mention is a chemical production facility. Again, the customer needed a single monitoring system for performance issue identification across multiple trains, continuous monitoring of the controller performance, and identify improvement opportunity to drive the operation to the optimal state. LPM solution was again implemented so that controller performance are monitored and KPIs are presented, and they are, like I mentioned, understandable and actionable. Analysis results are reviewed by ABB expert periodically to identify corrective actions and improvement opportunity. The annual economic benefits are estimated at between $350,000 to $460,000 for the first year. So at this point, I would like to open up for our last poll question for today. The question is, which of the following performance issues do you encounter the most in your plant? Do you encounter valve issues, for example, stiction sizing, or sensor measurement faults, or inadequate PID parameter settings? In other words, PID tuning issues. So again, you get a few seconds to answer these questions to the best of your knowledge. And we thank you and appreciate your response on these questions. Maybe just another few seconds. Oh, okay, so the poll is closed now. I don't see the results as yet. Okay, so looks like most people think that 50% people think that it's the PID tuning issue, and there are 1/3 of people thinking that it's sensor measurement issue. So just keep this in mind as we go through the solution. So now, so Lance, now let's move on to talk about the solution. Can you give a quick overview of the LPM solution?
Sure, Liwei. So if I break it down to the most basic concept, what we're doing is looking at the entire control loop, as you can see in the diagram, and breaking this into 3 distinct areas, each with a very specific set of calculations or analyses that generate relevant key indicators for that section. So the 3 sections that we analyze are signal, process, and control. And since data is really the fundamental input used to determine the other indicators, it's so important to ensure that the input data is good. Are we sampling fast enough? Is there any compression happening in the data? Is there missing data? So these kind of issues could result in missed analyses or false analyses in the other 2 areas. And so it's quite critical to address these signal indicators to make sure that the other 2 KPI areas are accurately analyzed. If we look at the control indicators, this is where we'll be able to see if the controller itself is having issues. So is there an opportunity to adjust the tuning? In other words, is our tuning too slow? Is it too aggressive? Or are we maybe missing some tuning parameters? So we've got a continuous offset in the control action, for instance. Is the controller moving the valve or actuator more aggressively than what's actually required? Are the controllers being used in auto, like they're designed to be used, or have most of them been switched to manual? So those are kind of the indicators in the control area. And finally, the third set of indicators will help us focus on understanding if the actual issues are there with our valves or actuators. So we look for incorrect sizing. Do we have leakage in the valves? Do we have stiction indicators in the valves or actuators? Then finally, are there any disturbances or oscillations that are actually coming from the process itself? And we pick up those disturbances or oscillations either intermittently or if they're there on a continuous, persistent basis.
So now let's talk about the delivery of the solution. So Lance, can you talk how ABB delivers the solution?
Yeah, so we've got a phased approach that we typically like to work through with our customers. And this approach allows us to quickly assess the situation with a high-level, quick turnaround analysis. And we call this a benchmark. And the main idea with a benchmark is to determine if there is enough improvement opportunity to justify moving to the next phase, which is what we would then call a fingerprint. So the fingerprint service connects our domain specialists to your control and process engineers, and a comprehensive engagement takes place to enable us to do some advanced configuration of the loop data collection and analysis engines. So typically during this process is where we configure the analysis engine to minimize false positives that would otherwise skew the KPI results. So we kind of configure the solution and the analytics based on how your regulatory controllers are designed to work. The fingerprint service also allows time for certain remediation activities to be completed. So not only do we want to identify where there are opportunities, but we actually want to go and make some changes and adjustments to deliver some value out of the fingerprint process. And then the final phase of the service would be what we call the optimization phase. And quite simply, this puts into place the infrastructure and the commercial agreement that enables a fingerprint type service to be done on an ongoing basis versus as a transactional service in a single point in time.
Thank you, Lance. So far, we talked about the business case, features and benefits of LPM and ABB delivery methodology, and provided some implementation examples and economic benefits. To help visualize how LPM can be used, can you please go through a use case on how one may use the LPM to identify performance issues?
Yeah, absolutely. So I've got a couple of screenshots prepared from a sample system that I'll use to give you a sense of how the system would help identify problem loops. And there are really 2 high-level views that I like to use to get an overall sense of the health of the controllers that I'd be looking after. So the first view that you can see here represents the analysis results in what we call a grid view or grid style, where for each loop I can see a traffic light representation of the KPI results. green, red, yellow, and I can quite quickly assess if there are loops with common issues. So I can see across my loops on the left-hand side and my KPIs on the bottom. If I've got a column of red, then I know I've got a common problem across all my loops. And if I've got a number of problems across a single loop, I'd see a row of red indicators, for instance. This view also has the ability to compare and visualize the differences between the analysis of different time periods. So I can use this view to see what changed from an analysis to analysis. The second view, which is the one that we're showing now, is what I would use as they call the event view. So this presents a normalized view of all the KPIs, and it's a very quick way for me to understand how many of my loops are showing certain KPI. So for instance, from this view, I can quickly identify all the loops that are in manual or that have an input signal issue by simply selecting the specific KPI I'm interested in. I can drill down and see a detailed list of the loops that are contributing to this KPI. So here you'll see the loops contributing to the KPI. From this drill down view, I can now also see for how much of the data collection period this specific issue was present. So the longer the bar graph, the more prevalent this issue was over the data collection interval. Once I have this view of the controllers in this category, I can now go ahead and drill down to the actual data set that was collected for this loop and investigate in more detail. So in the data view, I can straight away now see the specific data set in terms of date and time that was used to calculate this set of KPIs. I can see the raw data for this loop, as well as the various diagnoses that have been identified for this specific data set in this loop. So this loop has got a FCE problem and intermittent disturbance. From the patterns I'm seeing here, with the output having a triangle shape and the measured variable having a square wave shape, I'm pretty sure that this valve is showing signs of stiction and it needs to have some maintenance done. From this view, I can also easily navigate to other different time intervals for the same loop. So I can compare, how this loop performed historically, and I can also navigate to different loops for the same time period so that I can see if there were similar interactions for impacting other control loops. Since we've automated the data collection and analysis, I wanted to also quickly share one more key capability of the loop performance system. And as the new data sets are analyzed, any data sets that are determined to have sufficient natural movement in the set points and outputs are stored in what we call a loop tuning view. So if there are any tuning issues identified with these loops, so slow control or over control, then these stored data sets can be immediately used directly in our loop tuning package. This means it's not necessary to go back and bump or step test the process to gather additional data to tune loops that have been identified with tuning issues. So this again reduces the risk of further disturbing the process of the plant by having to do step tests, and it reduces the time required to retune the control loops. And so this is quite important, given that if you look at the analysis, most of you felt that most of the problems that you would be experiencing were related to PID tuning issues. So this would really help optimize the time required to address those issues. So if we look at the tuning tool, once the data set is directly imported into the tuning tool, this tool allows us to build a process model. And then that process model is used to support adjusting the tuning parameters, simulating those results, and evaluating how the tuning changes would impact the response of the control loop. The tuning tool also supports different types of tuning, as well as PID algorithms. So in fact, there are standard control algorithms built into the tuning tool, not just for ABB's DCS controller family, but also for the DCS controllers from several competitor systems. This again can be very useful to help if you have to convert tuning constants between different controller families.
Thank you, Lance. Lastly, I understand that to keep the LPM program up to date with the new technologies, ABB continues to invest in LPM development work. So can you just give us some examples on the developments?
Yeah, sure. So I'd like to just summarize kind of the two main focus areas I would say that are currently being worked on in the LPM solution. Highlighting here the key objectives of significantly enhancing what we call the track or notification capabilities. The intent is really to enable configuration of much more complex rules or monitors to help automate the monitoring and detection of more complex regulatory control issues. And we do that by combining underlying single loop analysis. So that's the first focus area. And then the second focus area in terms of the development is on a refresh of the user interface to align much more closely now with ABB's user interface design guidelines and best practices to provide this new user interface in a thin client browser environment. So you'd be able to interact with the loop performance system, look at the data using just a browser on your desktop. And for me, it's definitely exciting to see the ongoing enhancements that are being done. And I see the value that all our customers will benefit from these enhancements. So Liwei, thanks for inviting me to share my insights with you and some of the experience I've had with the LPM product. And I look forward to seeing how we can help our customers.
Thank you, Lance, for sharing your insights on LPM with us today. For any detailed information and a live demo of the tool, please contact your ABB account manager for additional information. So now I would like to open up for questions. I'll just give you a second for you to kind of, again, to remind you that the questions can be typed into the Q&A box, and we'll try to get to all of them if the time permits. But if not, it will be for sure to give you some, to give you answers through written emails. So at this point, I think I got one question